Hi, welcome back to season 2 of QuBites, your bite-sized pieces of quantum computing. My name is Renee from Valorem Reply, and today we're going to talk about quantum computing and the Internet of Things, or IoT in short. And for this, I'm happy that we have a special expert guest with us today, Giovanni Fazzi. Ciao, Giovanni. Welcome to the show. How are you today?
Hi, Renee. Thank you for inviting me.
I see some great books actually behind you, including some good stuff about the good old C, C++, and actually also a photo with your father, I think. So we have a little bit of family support here today, which is just perfect. And so can you tell us a little bit about yourself and your background, and especially how that relates to quantum computing?
Oh, yes, my studies were about maths, and I have started working on quantum computing since the beginning of 2018. My contribution is mainly related to quantum problems and quantum application from a mathematical point of view. My job aims at creating a bridge between business problems and quantum computers.
Nice. That's a great match for our show here, where we're focusing on the current impact we're already seeing with quantum computing. And so let's dive into today's topic, actually. What do you think? How is the Internet of Things actually related to quantum computing? Where's the cross path or cross section here between these technologies?
Oh, yes. Internet of Things is showing a developing technologies with a lot of scope in the future, and it can make easier a lot of tasks for us. But the technology is moving towards quantum computing, and Internet of Things, as well as other technology field, will be influenced from it. In my perspective, there are three main aspects. The first one it is the quantum cryptography for Internet of Things security. The second one is quantum AI. Let's say you get the data from your sensor or your device and then send them to a central point. Here you can run quantum algorithms and so you can exploit all the quantum processing power. The last one, it is the quantum optimization related to handle the Internet of Things infrastructure.
Gotcha. So basically you can, for example, apply quantum inspired optimization, which by the way, we covered in season 1. So if you want to learn all about quantum inspired optimization, watch some of the season 1 videos. We talked lengthy about quantum inspired optimization, right? But what you're saying is basically you can use these kind of quantum inspired computing algorithms like QuBo and so on to optimize, for example, where you could place your IoT sensors and other things where we need some optimization efforts, right? So that's great. But let's talk about quantum security a little bit. And what role does quantum security play in the IoT context? So can we dive a little bit deeper into this one?
Oh, yes, unfortunately, Internet of Things has many threats, like, for example, data breaches, data authentication, virus, side channel attack, and classical algorithms like, for example, RSA works well against current classical computers. But as I mentioned before, we are moving to a new era, the quantum computing era. And so the quantum processing power, it is then more than enough to break the current classical algorithms. Therefore, it is required that we have to design post-quantum algorithms in order to prevent our system from the breaches.
Gotcha. So basically there is this threat on the horizon that with quantum computing we can basically crack or like basically make the current cryptography and encryption algorithms obsolete, right? They will be crackable
Yes.
in a linear time, in fact, which you cannot do with classic computers at the moment. So that's this big threat. And so what can you actually do to mitigate for that? Or can you already plan for that? You mentioned these post-quantum algorithms, right? So that's probably something. Or what else can be done?
As a reply, we are working on the three main aspects that I have mentioned before. We have a department that are working on post-quantum cryptography algorithms, and we are testing it. Speaking about the project, one on top of my head, there is a project related to our telco customer. In line with that, let me define the concept of SON. SON stands for self-organizing network. So you have a telecommunication network made of different nodes, and these nodes has to find the optimal parameters by itself and looking the behavior of the other nodes. So this node sends the information to a central point, and here you have a quantum algorithms that run and is able to find the optimal solution and the optimal parameters. This optimal parameter then are sent back to the nodes. And this problem is quite hard since you have a lot of nodes, a lot of interaction, and plus you have to find a solution quickly. So if one hand you have your problems that becomes bigger and bigger and so more complex, you have that you have to find the solution very quick. So therefore, to solve this kind of problem, you have to use quantum computing or quantum-inspired algorithms based on GPU or TPU.
Gotcha. So basically applying quantum-inspired optimization technology for actually optimizing your IoT workloads in the end, right? And that's actually quite amazing that we're already doing this at Reply with customers in production. So that is pretty amazing. Well, we're already at the end of the show today. Thank you so much, Giovanni, for sharing your insights today. And also thanks for your father to supporting us in the background there. That is very much appreciated. Say hi to him. And again, thank you so much, Giovanni.
Thank you, Renee. It was a pleasure.
Great. And thanks everyone for joining us for another episode of QuBites today. Follow our social media channels to hear all about the next episodes when we will publish them. Also, our blog will have the new ones and also the previous episodes from season 1. So go and check them out. Thanks for your attention. Take care and be safe. Bye-bye.
Bye.